Hello, everyone, and welcome to today's Introduction to Machine Learning with Databricks, hosted by Thorogood Associates. So my name is Alaistair Jones, and I'm a US-based data and analytics consultant with Thorogood Associates. I'm joined by my colleague Deepika Bhatt, who is also a data and analytics consultant and is joining us from the UK. So today's agenda, well, we're going to start by introducing Thorogood and providing an overview of Databricks' relevant context. We'll then discuss the basics of machine learning kind of conceptually, before delving into a hands-on Databricks demo split into two sections, so data cleansing and training and applying the model. We'll then share some information on MLflow, which allows you to industrialize ML solutions, and we'll conclude with next steps as a kind of parting thought. So let's start with an introduction to Thorogood and an overview of Databricks. Thorogood is a specialist data and analytics consultancy. We're independent, global, and customer-centric. Our consulting approach means that we seek to internalize the business objectives of any engagement, pair that with our data and analytics expertise, and deliver quality outcomes for our clients. We have offices in the UK, US, Brazil, Singapore, and India. We offer a range of services, but the bulk of what we do is solution design and development, for example, with Databricks, but that also informs our ability to deliver strategies and roadmaps, trainings, and empowerment initiatives, as well as maintenance and support projects. Thorogood is independent, as I mentioned, and that means that we maintain close partnerships with many of the key vendors in our space. A key partner for us since 2018 is Databricks. We enjoy close collaboration with Databricks across our offices in different regions, and we were recently invited as one of 4 consulting launch partners for Databricks as they released their SQL Analytics offering. And we're continuously collaborating on joint marketing and customer initiatives. We also have established partnerships with the major cloud vendors, Microsoft and AWS. We are a managed and a gold Microsoft partner with several relevant competencies. So we deliver value in data engineering, data science, and data visualization in those spaces for key enterprise customers, typically within the data-rich verticals of consumer goods, pharmaceuticals, banking, and insurance. Key customers include Unilever, Johnson & Johnson, Liberty Mutual, Morgan Stanley, Mars, Gen Re, and some of the other names and logos that you see on the screen. So now we'll move on to provide a bit more context on Databricks. So Databricks fundamentally comes from the creators of Apache Spark, an open source platform that is used for big data engineering and large analytics workloads. Databricks was founded as a private company to help build upon the Spark foundation and enhance it for enterprise organizations' use. They've created the Databricks service that they aptly refer to as a unified analytics platform. The Databricks platform sits on major clouds, including Azure, AWS, and as of recently, GCP as well. It gels nicely with other data platform offerings in these stacks and can fit the needs of both kind of data engineering and data science use cases. It's often a component of effective cloud data architectures. As it's a cloud platform, it's very effective at auto scaling, only using the compute power needed at that point in time. Its notebooks can also be authored in a variety of the most popular languages used by data scientists, engineers, and analysts alike. So SQL, Scala, R, and Python. And we'll see that during today's demo. Some features of Spark that have been enhanced and are available on the Databricks platform on the data engineering side, well, it fits nicely with the native Azure and AWS kind of data storage services like ADLS and S3. So it can leverage those kind of go-to data lake storage options. But also, Databricks has created Delta Lake, which is now an open source offering, and it allows for a bit more kind of structure and reliability for your data engineering in the cloud. In terms of the data science side of things, well, it comes with a lot of libraries and packages pre-installed, so it's kind of quick to get up and running as a data scientist. But it also has the addition of the MLflow capability. We'll touch on that at the end of today's session. But that's, again, something that was created by Databricks, is now an open source, and it's a very effective tool for kind of ML model tracking, and we'll explain a bit about what that means. So that's kind of a grounding in Databricks. So now that we have a bit of a background on Databricks, let's move on to discuss machine learning basics and then kind of tie these things together and talk about how Databricks can effectively tackle ML workloads. Well, the first thing to note about machine learning is that it's everywhere and its presence is only increasing. So some examples that you may be familiar with are noted on the screen. For example, your email spam filter or your credit card's fraud detection service may use classification algorithms to detect where an email or a transaction is likely to be unwanted and fraudulent based on some key attributes. Netflix or e-commerce websites may use kind of cosine similarity algorithms to recommend movies or products that may suit your tastes based on the taste preferences of others with similar kind of histories and preferences to you. So that's exciting, but how does it work? What are the key steps in a machine learning initiative? Well, obviously, you start with some data. And as I walk through this example, I'll use a kind of a hypothetical scenario. We'll have data on people that may or may not be professional football players. We'll have a data set containing information on a group of individuals, such as their height, weight, 100-meter sprint speed, their credit score, their eye color, and their birth month, and of course, whether or not they're a professional football player. These attributes, such as height, weight, and credit score, are features, and the label is whether or not that person's a football player. An output could also be numeric, like salary, so we could be predicting salary, in which case the label is a quantity, and we may use a regression model to predict that quantity. So the first step initially, what we'll do after kind of cleaning up the data, and I'll show that in Databricks, is we then split the data randomly into a training data set and a test data set. We can then select which features we want to use and how. So in this example, I don't think eye color or birth month or even credit score are particularly as relevant and won't have as much bearing on whether or not someone is a professional football player. But I definitely suspect maybe height and 100-meter speed could be correlated to being a professional football player. So then we select the algorithm for our model, and we'll explore how we decide on an appropriate algorithm to use in a moment. In this instance, I'm going to use a basic clustering algorithm that groups people roughly based on height and 100-meter speed into football player or non-football player clusters. We then feed our model the training data so it can begin to establish these groupings and clusters of values that lean towards football player or not. We then run our test data through this trained model to understand how accurate the model is. We can kind of see the result of the evaluation from our model alongside the actual values. In this evaluation, we can look at how many football players we correctly identified, how many non-football players we incorrectly classified as football players, and all those kinds of permutations. And that allows us to refine our model in many senses. We're able to kind of iterate over time and refine aspects of our model. Perhaps we want to use different features, so weight and 100-meter speed, or just weight and height. And ultimately, once we're happy with the model, we can look to industrialize it, bring in some of our enterprise data, and we can industrialize it using the process of MLOps, which is supported by an offering like MLflow, and we'll touch on that, as I said, towards the end of today's presentation. So I'd mentioned the kind of selection of an algorithm, and it's an obvious question. How do we decide on an algorithm to use? So let's get into that. So how do we decide on an algorithm to use? Well, fundamentally via exploratory data analytics. We look at facets of our data, including distribution, feature interactions, missing values, variable types, need for accuracy. And there are different ways of conducting this exploratory data analytics. You can do some basic data visualization in popular and common BI tools. You can cleanse your data. You can leverage data summaries, which is something that's available in analytics and ML tools like Databricks. You could look at the relationships in your data, again, in a BI tool or a tool used for kind of relational modeling. We then pick an algorithm, which in the world of supervised machine learning at a high level could be a classification predictive model or a regression predictive model. And classification fundamentally groups attributes to kind of categorize data, and regression will define a best fit line for the data so that an input value can return an output value in line with the other kind of data points it's been fed. And I talked about the kind of the life cycle of an ML project, and evaluation is a key component of that. So it's important to evaluate models, and there are different ways of evaluating model depending on which type of algorithm you use. So at a high level, I'll first talk about evaluating a classification model, particularly a simple kind of binary classification model with two outputs, so football player, not football player, for example, or spam or not spam in the case of your email filter. So we can think of that as a kind of a 2x2 matrix, and that captures positives and negatives, and true positives, true negatives, and the false positives, false negatives. So there are different ways that we can look at how the test data fared in our model. And we can look at the accuracy, the precision, and the recall, and these all kind of mean variations on how our model is performing. We can decide to refine our model give kind of preference to one of these metrics over another. So for example, we may never want a spam email to get through to people's inboxes. So maybe recall and the proportion of actual positives that were predicted is more important than maybe some of the other metrics. So we can optimize for any of these metrics. Evaluating a regression model, well, that's a little different. Effectively, on the left-hand side of the screen here, you can see a basic linear regression model that's fit to data. The vertical distance between data points and the regression line is called the residual. How we evaluate a regression model is essentially to calculate mean squared error and R-squared coefficient, so at the bottom of the screen on the right-hand side. These are different measures that describe how effectively a regression model predicts values. Our model can contain bias and underfit, where the model is poorly fitted to the data, or variance and overfit, where the regression is too specifically fit to the training data. Actually, today's demo will be a regression model. So we'll go into more depth with some of these metrics of evaluating a regression model, and hopefully that gives it a bit more context and makes a bit more sense when Deepika touches on those topics. So without further ado, let's jump into Databricks and kind of see machine learning in action. So here we are in our Databricks workspace. We're in a particular notebook. In this case, it's called data cleansing. The first step when approaching machine learning is to prepare the data through the appropriate kind of data and feature engineering steps. So next to the notebook name of data cleansing, you can see the default language for this notebook is set to Python. But in any of the subsequent kind of command cells, we can very simply alter the language with a brief statement at the start of that cell, so we can leverage SQL if we want to, or R. A notebook generally consists of a sequence of command cells that perform a function. But on the left-hand side of the screen here, you can see kind of a pane that allows us to navigate around the Databricks portal. So we can navigate to other workspaces that contain their own notebooks, for example. Towards the bottom of the screen, you can see here I have the ability to jump between the kind of SQL Analytics interface and the Notebooks interface. So the SQL Analytics interface is an entirely different view of Databricks and looks and feels a lot more like a traditional SQL query editor as opposed to a notebook like this. If you're interested in learning more about SQL Analytics, there's a good deal of content on Thorogood's website, so I'd recommend you go there, but it's a different way of interacting with data through Databricks. At the top of along the top of the notebook, we can see a ribbon with various options, as you kind of would expect from a lot of interfaces that people use. So we've got File, and within that, we could maybe clone a notebook. We've got Edit, which allows us to kind of copy cells. We have the ability to add comments. We have the ability to check revision history. So today we're going to be looking at Airbnb data, and it's kind of scraped from the internet and read into and stored in a CSV file. So initially what we're doing is kind of reading the data from that CSV file. So we can display that raw data frame that we've read in from the CSV file to understand a bit more about our data. We can also just look at all the columns in our data frame that we've loaded. So we've got a number of columns here. Maybe not all of them are relevant. So what we're going to do as a first kind of step in this data feature engineering is just to think about what columns do we think are relevant for our analysis, what do we want to retain. So we've specified here with a Python command which columns to keep. We're going to apply some more filtering. So we're again displaying our data frame at the end of that step. And there are certain things that we want to make sure that we're filtering on, so I can also interact with the table when I'm displaying the data frame. So minimum nights is one of our columns in this data frame, and something that we want to do is ensure that we're filtering out values appropriately. So we want anywhere with minimum nights under 365. So we want places that are for rent for less than a year, essentially. We'll also have to do some conversion of data types. So at the moment, for example, if we take a look at our data frame, and I'm just going to scroll to the right here, we can see that, for example, our price is listed here as a string with this kind of $sign, and that's something that we'll need to do some engineering on. So we'll need to change that. So we'll write a brief kind of cell here that converts that price column, removing the $sign and converting the data type. I mentioned when thinking about kind of which type of algorithm to apply, you might want to do some data summaries. So that is something that we have done here. We've summarized our data across all the columns, but really we're going to be looking at predicting price by any of our features. So what I'm going to do is look at the summary of our price column, and we can begin to see some interesting things that we may want to address. So for example, we have prices here. We have min prices of 0. So that's a bit of an outlier. That's something that we don't necessarily want to, we don't want instances where price is 0. That doesn't make much sense to us, and that may throw off our analysis. So what we're going to do is actually just filter out, filter that price column and filter out where the price is 0 and make sure all our prices are positive. Kind of a final step here is we need to think about how we handle nulls. So nulls can negatively affect our models, and we need to make sure that we are cognizant of that when we're doing some of the data and feature engineering. So what we're going to do is use Databricks imputer essentially to create and convert columns and handle these nulls. So at first, we're going to look at where we have null values, and where we do, what we're going to do is just we're adding a column that captures that there is a null value for that measure. We've appended some columns to flag that. But finally, what we're going to do is just use a median value. So where there are nulls, instead of using a null, we're going to use a median value in that column, thereby eliminating the risk of having nulls throwing off our model. So now that we have our kind of data appropriately cleansed and ready for machine learning, we'll save the data frame to a Delta file. So I talked about Delta storage. And what I'm going to do now is hand over to my colleague Deepika, who's going to walk us through the training and the testing of this model.
Thank you, Alaistair. And I will just start sharing the second part of the content, which is the training and testing of our model. So now that Alaistair has already cleansed our data, what we are going to do is go to the next section, which is the training and applying of this model. As you can see, what we have done here is split our data cleansing and training and applying of the model into 2 separate notebooks. Again, a quite nice and modular approach in case you wanted to keep a track or keep a segmentation between the data engineering and the data science part of your experiment. So first thing what we are doing here is just reading that cleansed data that Alaistair has already done in the previous section. Now, as we were talking about earlier, we generally will split our data into 2 sets, which is the training and testing data sets, so that we have one version of the seen data, which we are going to train our model with, and then an unseen data set, which is going to be the test data. And we're going to look at it for the accuracy and prediction before we can judge whether our model has been successful or not. So as we look at this cell, we are starting with splitting our data randomly into with an 80-20 percentage of using 80% of data for training and rest of the 20% for testing. In this case, we are just using a random split because our data is not in any chronological order or ordered in any specific way. But you might have to think about those scenarios if you're getting your data in a fixed order. So the next step in our notebook is we're looking at setting a baseline model. This is a model we will judge the accuracy of our model against. In this case, what we are doing is creating a prediction column, which takes the literal average of the price from the training data set. And we will see how accurate this is as a predictor for our test data set. So as you can see, the average predicted price is 215, and that's the actual price of the rooms in our data set. We use a Sparks regression evaluator to evaluate this prediction column against the actual price. Again, we're using the estimator and transformer as we discussed in the imputation section. What we do is we get a root mean squared error value, which is one of the evaluators of the model, of a linear regression model, as Alaistair was mentioning, and the value comes out to be 178. Now, if we want the model that we are creating to be successful, we want it to be at least lower than this value for it to be effective, because otherwise using just an average price would have worked worked in our case. So once we have created this baseline model and we have a target score that we are trying to beat, we will move on to the next section of doing the actual or creating our own linear regression model. So in this case, what we are doing is taking a very simple case. As you can see, there's a lot of different parameters which are available in a data type. But for simplicity, what we are going to do is we're using just the number of bedrooms as the key parameter for predicting the price for the property. The first step is just we are trying to look at the data, and as you can see, it is the cleansed data that we are seeing now. In the next step, we are going to create our linear regression model. We define our estimator and show that, and as you can see, our fitting estimator, this particular command cell has failed, and it's thrown an error of saying that the data type does not match for the key column number of bedrooms that we are planning to use. What has happened in this case? This is because the Spark's linear regression estimator, it requires a vector type for it, any of the feature columns that are being used. So in this case, if you're trying to, if we want to use this particular linear regression estimator, we need to convert our data set into a vector format. The vector type becomes extremely useful when we are using categorical features, that is any non-numerical features for analysis. But in this case, even though our actual column that we're using is in numerical format, but we still have to follow the rules and turn it into a vector type. So to create this vector type column, we are here using a vector assembler. And this will take all the columns we want to use as features and convert them into a single vector column. So if I just scroll to the right, you can see what a vector data type looks like. So in this case, it's not showing you the most intuitive values because we're not using a combination of features, but just the number of bedrooms. Once this data transformation is done, we can move on to actually creating our model. So once we apply this vector assembler to our bedrooms column, we have our features column in vector format, which we are going to be using to create our model. We then can now finally fit our linear regression estimator onto the training data set. And basically what we are trying to do is tell it to learn the relationship between the number of bedrooms and the price from the training data set, and ultimately produce that linear regression model. Once that is done, we are in the next cell, we are trying to see what is the actual relationship that our model has learned. So this equation is doing nothing as an output, but giving us what is the best fit that it has found from our training data set. And now that we have the linear regression slope that it can use to predict for the rest of the, or that we can use for our future predictions, we will run our data model against the test set to see what the actual output looks like. So in the next step, we are applying this model that we have created into our test data set. So remember that this test data set, our data model has never seen it before. And as we look at the output, it has predicted some values against the, and we can test it for accuracy against the actual price we have already present in our data set. So when we finally evaluate our model and calculate the root mean squared error, so remember we were targeting to get a value of lower than 178, and hooray, we have done it, and it's evaluating to 149. So we have effectively created a model which is better than the initial baseline model that we were working with. So that's only the first step. And in this case, as you can see, this is just me doing an ad hoc experiment or creating a model and just testing my result. A few other points to think about when it comes to productionizing machine learning. We see a few common challenges like, keeping track of your experiments and model development can be very hard. Reproducing code or comparing models can be very hard between data scientists. And also the standardization and packaging and deploying of models can also be quite challenging. The solution for that, as we were talking about, MLflow, which is an open source platform for machine learning lifecycle, can help in operationalizing machine learning, and It's again another offering developed by Databricks and comes pre-installed on the Databricks runtime for machine learning. The 4 key components, as you can see on the screen, are tracking, projects, model, and model registry, which can help you record and query your experiment, package them in a format that's reproducible, and standardizing these models and the deployment paths, and finally having a centralized model management for reviewing and sharing. So we don't probably have time to go into a lot of details, but I'll probably try to quickly demonstrate how you can do the same thing. So the same steps that I had followed earlier, I have sort of replicated that in an MLflow run. And once you run it using MLflow, you can also log certain parameters and track your experiments. So once you run it within MLflow, what you can see is that there's this experiment tab. And every time you run an experiment, you can capture or log its results. So if I quickly browse through what are the different features that it has to offer, you can look at the different parameters and metrics that were associated with a particular run of the experiment. And not only that, you can also log certain. So in this case, I had specified that I want to track the price distribution for each model run, and that output has been saved here in my experiment. What you also have is exportable copy of the model code, which again is callable and can be executed in other frameworks as well. So once you have, and this makes it quite easy for you to track the different runs of your experiments. The other thing what you can do is also register your model. So this is just looking at our different experiment analysis. But once you've registered your model, the model will start appearing and based on who you have shared access with, you can start seeing your models in this model framework. What it does, it makes it quite easy for you to collaborate with your colleagues. As you can see, in this case, I'm collaborating with my colleague, Liam, and there are different versions of the model that we have created and have been working together on. And once you look at the individual versions, you have options like, again, in this case, I've requested moving the stage to staging, but what you can also do is if you wanted to push things to production. So if you've worked with GitHub, you can almost associate it with a very collaborative way of working where you can move things, archive things, move them to production within the same framework, and in a very simple way, manage different versions of your machine learning models. So I'm afraid that's all we had time for in the demo today. So we've come to the end of today's session. I hope you found this useful. On the screen, I've also brought up a few Thorogood offerings that might be of interest, whether it's getting starting with your Databricks journey or with a taster workshop, or proof of concept like solutions for identifying key use cases to enhance your data and insights with Databricks. And if you have any other questions or are interested to learn more, please don't hesitate to reach out using the contact details on the screen. And we also have a very packed calendar of webcasts and workshops across the UK, US, and Singapore and Brazil. Details on a couple of these events are on your screen, but do check out our website for the full list on www.thorogood.com/events. We also have a variety of pre-recorded content, which is available on demand on our website. Again, if you go on our website /perspectives, you should be able to access these. So with that, we come to an end of this session. Once again, thank you very much and have a good rest of your day.